For the polar equation r equals 4 over 2 minus cosine theta, express the polar equation in parametric form. Then use a graphing device to graph the parametric equations found in part A. First, to parameterize a polar equation, we would use x equals f of t times cosine of t and y equals f of t times sine of t, where f of t is actually r, where r is expressed in theta. In this problem, r equals 4 over 2 minus cosine theta, so f of theta equals 4 over 2 minus cosine theta, and so f of t equals 4 over 2 minus cosine of t. Therefore, we have parametric equations. X equals f of t is 4 over 2 minus cosine of t times cosine of t, and y equals f of t, which is 4 over 2 minus cosine of t times sine of t. Simplifying this, we have x equals 4 cosine of t over 2 minus cosine of t, and y equals 4 sine of t over 2 minus cosine of t. And these are parametric equations for the polar equation r equals 4 over 2 minus cosine of theta. If we parameterize this polar equation correctly, then the graph of these parametric equations should be the same as the graph of the polar equation. To graph the parametric equations using Desmos.com, we simply put the parametric equation in the set of parentheses. Open the parentheses, type the formula or the expression for x of t, comma, type the expression for y of t. Close the parentheses. Also, specifying the domain of t, use a different domain to see what happened to the curve. For example, if we were to use 0 to 2 pi for t, then the graph of the parametric equation is almost a circle, but not quite a circle in this case. It is an ellipse. If we were to graph this equation in the same coordinate axis as the polar equation r equals 4 over 2 minus cosine theta, we see that both of them are the same curves. So we parameterize it correctly.